Hello everyone, welcome to my video lecture. So in this video, I will discuss about some more protocols under random access. The first protocol is called as CSMA, that is Carrier Sense Multiple Access. So in the last video, we have discussed two protocols under random access, that is Aloha and Pure Aloha, and we have discussed what is the vulnerable time for both, and we have seen that the vulnerable time for Pure Aloha was two times the frame transmission time, and after that in slotted aloha it was reduced to one transmission time, that is frame transmission time, that is 1 TFR. And now again we are going to discuss some more protocols so that we are able to reduce the uh, collisions. So here we have a protocol called as carrier sense multiple access where we try to reduce the collision. So the main principle behind this carrier sense multiple access is sense before transmit. So that is why the name is carrier sense multiple access. So whenever a device wants to transmit the frame to the medium, it has to sense first. If the medium is idle, that means no other data is carrying by the medium, then only the device can transmit its frames. So that is why it is called as carrier sense multiple access. It is just like whenever two persons is talking, the person has to listen first. If other person is not talking, then he can talk. So then only there will be effective communication between the devices. If two persons talk simultaneously, then obviously there will not be an effective communication. So that is why listen before talk. The same principle we use here, that is sense before transmit. So that is the main principle in carrier sense multiple access. So sense before transmit. And here we cannot say that the collision is completely avoided. So it is reduced, but collision, there will be collision. So here the collision is because of propagation delay. So we'll discuss that in detail. So if I consider this diagram, so I'm considering four devices A, B, C, and D, which are connected to a single, that is same transmission medium. So consider at time t1, device B sends the medium, and it finds medium is idle. So that is why it transfers the data or frame. So now here we can see that, so this is the frame which is belongs to B. So because of this propagation delay, the slope whatever we can see here, it is the propagation delay. So whenever it reaches the first bit of B reaches the C at this point. So that is why whenever C sends the medium at time t2, that is in this time, now again C also finds the medium is idle. So that is why again it will transfer. So because of propagation delay at this point of time, there will be a collision between the first bit of frame which is sent by B and which is sent by C. So that is why after this, there will be a collision in this area. So this is the area where the medium contains both frames of B and C. And here, this is the content where I have only C signal. That is frame which is sent by C. So that is why because of propagation delay, there will be a collision in CSMA protocol. So if at all we want to discuss about vulnerable time, so again I'm considering the same example. So we'll see how the vulnerable time of CSMA is equal to propagation time. So at time t1, A sends the data or frame, it finds the medium is idle and it transfers the data. So at this particular period of time, because of propagation delay, so B finds the first bit of frame which is sent by A. So at this particular period of time, so first bit of frame will be received. So that is what we called as propagation delay. So propagation delay or time is nothing but time required to transfer the first bit from sender to receiver. So that is why if at all device B sends the medium between this time, then it finds the medium is idle. That is why whenever it transfers the data, there will be some collision. So that is why the propagation delay is the vulnerable time. So again here also, so this is the propagation delay for C, that is nothing but at this period of time C receives the first bit of frame which is sent by A. So if you see here, the propagation delay gradually increases whenever distance increased. Okay, so whenever I consider propagation delay at C and at B the propagation delay is very less because B is nearer to A than C. So that is why, so here, whenever C sends the medium at this period of time, it finds the medium is idle, and if at all it sends, there will be collision here, somewhere here. So that is why, so vulnerable time is equal to propagation time in CSMA protocol. So normally we write propagation delay or time as TP. So that is why we can say that the vulnerable time in CSMA protocol is equal to 1 propagation time. So now, whenever device sends the medium, what actually the device has to do whenever it finds the medium is idle or whenever medium is busy. So for answering these questions, so they have given with 3 persistent methods, that is 3 strategies we have. So those are one persistent, so one persistent, non-persistent and p-persistent. So these are the 3 persistent methods, so that actually answers or decides what the device has to do whenever it finds the medium is idle or medium is busy. So we'll see what is the behavior of these persistent methods. So if I consider first one, in one persistent, the medium is continuously sensed by the devices whenever it is busy. So that is why in this time it finds the medium is busy. That is why there is a continuous sensing of medium. So until it finds the medium is idle. So in one persistent, the device will continuously sense the medium until it finds the medium as idle. Once it finds the medium as idle, then it can transfer the data or frame to the medium. So that is called as one persistent. Second one is non-persistent. So here initially it will sense the medium. If at all the device finds the medium is busy, then it will wait for some time. Again after some time, then it will sense. So here continuously sensing is not there. So first it will sense. If it is busy, then it will wait for some time, and again it will sense. If at all again it finds the medium is busy, again it will wait for some more time. So then again it will sense. If the medium is idle, in this case it is idle, then it can transfer the data or frame. So that is non-persistent. So if I look into one persistent and non-persistent, so here one advantage is immediately whenever medium is idle, the device can transfer. So there is no wasting of bandwidth in the one persistent. If at all we look into this one, even though in this time, even though medium is idle, because of this waiting time, the device cannot transfer. So that is one disadvantage of this non-persistent. And here continuously we have to sense. Even though it is busy, continuously we have to sense here. So continuous sensing is not required. So that is why this is the one advantage. So that is why by combining advantages of these one persistent and non-persistent, we have one more method that is called as p persistent. So where p is nothing but the probability outcome. So here we are combining both procedure of one persistent and non-persistent. So we'll see how it is done. So in this p persistent, so the device medium will be sensed continuously until it finds the medium is idle. So whenever it finds the medium is idle, it will check for probability outcome. So it will check for a random number r. If this r is lesser than p, then it can send the frame. Otherwise, if r is greater than p, then it has to wait for some time. And it has to go for a back of time, and then again it has to check. So again it has to choose the r value. So here whenever it after some time, again whenever it sends the medium, if it finds the medium is busy, if it finds medium is busy, then it has to wait for some back of time. This is just like retransmission. Okay, so again it has to check. whenever it sends the medium here, it finds the medium is idle. Again, it will check a random number whether R is less than P. If the R is less than P, then it can send. So that is why here the main thing is whenever medium the device finds the medium is idle, it has to check for a random number R whether it is lesser than the probability outcome. So that is the main thing here. So we'll discuss same thing in the with the help of flow diagram. So this is a flow diagram for one persistent. So here continuously sensing is required. So whenever it is not busy, the medium is not busy, or whenever it is idle, then it can transfer the frame. So in non-persistent, it is not continuous. So whenever the channel is busy, it will wait for some time randomly, and again it will check. If it is not busy, then it can transmit the frame. So in P persistent, so initially it will sense the medium continuously. Whenever the channel finds it as idle, whenever the channel is idle, then it generates a random number which is between 0 to 1. If this random number is lesser than or equal to P, so where P is the probability outcome, then it can transfer the data. Otherwise, it has to wait for some time slot. Again, it will check the medium is whether medium is busy or idle. If the medium is busy, then it will use a back off process. That is, it will wait for some back off time. Otherwise, if the channel is not idle, again it has to go for generating a random number. So this will repeat. So this is what one persistent, non-persistent, and P persistent. So this is all about CSMA. So CSMA has two variants of protocols. One is CSMA CD, that is carrier sense multiplexes with collision detection. So this one is implemented in standard Ethernet. So Ethernet is one of the standard of wired LAN. So in that we have used CSMA CD. So in this carrier sense multiplexes with collision detection, station monitors the channel after sending a frame. So here a frame will be sent to the medium and it will check whether there is any collision or not. If there is any collision, then the device has to retransmit the frame. So this will be repeated for every frame. So this is a repetitive procedure. So if there is a collision, the frame has to be resent. So this is the main idea behind carrier sense multiple access with collision detection. So mainly used for wired LAN. Okay, so here we'll see how the collision happens. So I'm considering the same example. So there are four devices which is connected to a medium. So at time t1, A sends the medium after applying the one of the persistent method. It will sense the medium is idle and it transmit the frame. It starts transmitting the frame at time t1. Okay, so now at time t2, if you observe, t2 is after t1. Okay, so at time t2, the C did not receive the first bit of A. So because of propagation delay. So at this time, the C finds the medium is idle, then it starts transmitting the frame. But after some time, so because of propagation delay, at this point, there will be a collision between first bit of A and first bit of C. But actually, because of propagation delay, A identifies that there is a collision whenever it receives the first bit of C. So at this time, at time t4, A receives the first bit of the frame which is sent by C. And at this particular period of time, at time, t3, C receives the first bit of frame which is sent by A. So that is why whenever it finds the bit from other devices, it stops sending the frame. So that is what I told in the previous slide. So sending a frame and detecting a collision is repeating procedure in CSMA CD. So it transfers the frame and it wait until it receives the collision. So once it receives the collision signal, then it stops the sending of frame. So that is why if you consider, so here, if at all we consider the frame transmission time, that means how much period of time A transfers the frame, that is nothing but T4 minus T1. But if you observe for C, it is T3 minus T2. So why? Because C received the first bit earlier than A received the first bit from C. That is why, so it is able to send only this much of frame and A transmitted this much of frame. But here frame transmission is not successful since there is a collision. A stops sending the frame at time T4 and C stops the frame at time T3. So now both the device has to retransmit the frame. Okay, so now here what happens if at all the frame is entirely sent to the medium before it receives the collision signal. So here if you see, we don't have any acknowledgement. So there is no concept of acknowledgement in CSMA CD. So always a device needs to decide whether the frame transmission is successful or not based upon the collision. So now always device need to receive the collision signal, if at all there is a collision, before it completes the frame transmission to the medium. So that is why whenever there is a collision, the device has to uh, identify the collision before it completes the transfer the frame to the medium. Otherwise, it does not keep any copy of the frame and it cannot do retransmit the frame. So the frame will be completely lost permanently. So that is why here, so they have decided the minimum frame size so that the device can identify the collision before it completes the transmit the frame to the medium. So based upon the study, it is given that the frame transmission time, that is TFR should be at least 2 times the propagation delay. Here, so this should be the frame transmission time in CSMA CD. So we'll see one with an example. A network using CSMA CD has a bandwidth of 10 Mbps. So this is the bandwidth. If the maximum propagation time is given by 25.6 microsecond, including all the delay, what is the minimum size of the frame? So we know that frame transmission time should be at least 2 times the TP, and TP is already given, that is 25.6 microsecond. That is why frame transmission time will be 51.2 microsecond. So that means if at all the device wants to identify the collision before it completes the transfer the frame, it has to transfer the frame for at least 51.2 microsecond, up to 51.2 microsecond. If at all it completes before that, then it cannot retransmit the frame. Why? Because there is no copy. So if at all I want to, the device wants to send for this much period of time, what should be the length of the frame? What should be the number of bits in that frame? So that can be identified with the formula. So we know that frame transmission time is given by size divided by bandwidth. So this is a normal formula we use to find the frame transmission time. So in this case, what we need to find? We need to find the size, and bandwidth we know that is 10 Mbps, and frame transmission time we have already found, that is 51.2 microsecond. So based upon this formula, we got size is equal to 512 bits. So that means a frame should contain at least 512 bits so that it can transfer the frame till 51.2 microsecond. That is nothing but 64 bytes. So actually this is the minimum frame size in standard Ethernet. Okay, so this is a flow diagram how actually the CSMA CD works. So just like it look like a Aloha, but we have difference in that in this. So we'll see how it works. So initially, whenever there is a frame from a device, initially it will initialize a k parameter k, which actually track the number of times a frame is retransmitted. So initially it is initialized to 0. Then it has to go with one of the persistent methods, whatever we have discussed. So whichever we choose, that particular flow diagram will be included in this position. And whenever it finds the medium is idle, it transmits the frame and it will check whether there is any collision or not. So either completely frame is transmitted or whether there is any collision. So if at all there is a collision, then we have to retransmit. If there is no collision until we completely transfer the frame, then it is decided that the frame transmission is successful. So that means the frame is received by the receiver without any collision. Now, if at all there is a collision, now a special signal will be transmitted by the device which finds the collision in the medium. So that signal is called as jamming signal. So this jamming signal indicates other devices about the signal so that they will stop sending the frame or they will stop sensing the medium. So that is for the use of jamming signal. So this jamming signal will be sent by a device which identifies the collision. So after sending the jamming signal, the k value will be incremented by 1 and it check for the threshold value of k. If at all k value is more than 15, then it has to abort the transmission or it has to choose for a random number R for identifying the backup time. So this is same as your Aloha protocol. So random number will be chosen between 0 to the power k minus 1 and TB will be calculated which is equal to R into frame transmission time. So that much period of time will be waited to reduce the collision and again it has to try for retransmitting the frame. So this is what the flow diagram for CSMA CD. Now, how the device will identify whether the medium is idle or whether there is a collision in the medium or there is any data from the device. So that is based upon the energy level in the transmission medium. If the energy level is 0, then it is decided that the medium is idle. So if there is no signal, then obviously the energy level of the signal in the medium will be 0. So that is why it is the idle condition. If the energy level is normal, then it is successfully captured the channel and it can transfer the frame. So that is the normal level. If the signal level is abnormal level, that is more than the normal level, then there is a collision. So that is why based upon the signal levels or energy level of the signal, a device identifies whether the medium is idle or whether it transfers the frame or whether there is any collision in the medium. So this is all about CSMA CD. So CSMA CD we use for wired LAN and here we don't use any acknowledgement. Frame transmission need to be identified with the help of collisions. So if there is no collision until it transmits the complete frame, then the frame transmission is successful. Otherwise, if there is any collision, it has to stop sending the frame and it has to send the jamming signal, then it has to retransmit the frame. So this is what CSMA CD. So next is CSMA CA. So CSMA CA stands for Caressence Multiple Access with Collision Avoidance. So that means, so here we are trying to avoid the collision. So this CSMA CA protocol is designed for wireless LAN. So that means the devices are connected with wireless communication and whenever we use wireless LAN, then for that they have designed the protocol carences multiple access with collision avoidance. So why we need to avoid the collision? So why? Because in the wired LAN or whenever there is a physical link between the devices, it is easy to identify the collision based upon the energy level. But in this wireless LAN, it is difficult to identify the collision. So that is why we have to avoid the collision. So we have to prevent the collision. It is just like prevention is better than cure. Okay. So in order to avoid the collision, CSMA CA uses three strategies to avoid the collision. So first one is IFS time, that is interframe space time. IFS stands for interframe space. So next, second one is called as contention window, and third one acknowledgement. So unlike CSMA CD, so here we use acknowledgement. Along with that, we use IFS and contention window mainly for avoiding the collision. So we'll see how actually it works. So initially, the medium will be sensed continuously whenever it finds the busy, and once it finds the medium is idle, instead of sending directly, it will wait for some more time, so that if at all any other devices already send the data to the medium during this period of time, so this device will receive the signal so that it can stop sending the frame to avoid the collision. That is why the device, whenever it finds the medium is idle, immediately it will not send the frame. Instead of that, it will wait for some time. So that time period is called as IFS, that is interframe space. So after waiting for some period of time, again it has to wait for some more period of time. This is called as contention window. So this value will be between that is exponential value. So either 0 or 1 or 2 or 4, like that it goes. Okay. So where in contention window, the entire time is divided into time slot. So one time, sometimes it will be one time slot, sometimes it has to wait for two time slots. So that is based upon the number of times we are retransmitting the frame. So that is called as contention window. So contention window is a time where the entire time is divided into equal number of slots, and the size will be binary exponential. So here, whenever, for example, a device has to wait for two time slot, so consider whenever it waited for one time slot, whenever it uh, check the medium, it finds the medium is busy, then no need to again wait for two time slot. So here it can stop the timer, and after it finds the medium is idle, then it can wait for one more time slot. So that is what the one advantage of this contention window. And with the help of IFS, we can also provide priority for a station. So that means whichever device has lower IFS time, then that particular device has the higher priority than whichever device has higher IFS time. So that means a device with higher priority need to wait for minimum number of time, minimum time. And in contention window, if the station finds the channel is busy, if it does not restart the timer, so that's what I told in contention window, it stops the timer and restart whenever the channel becomes idle. So that's what I told here. And the last one is, so after waiting for this much time, even then also if it finds the medium is idle, then it can transfer the frame. Okay, so here it has to wait for this much period of time. So one is IFS, after that contention window, even after that whenever it finds the medium is idle, then it can transfer the frame. So here after sending the frame, it will wait for acknowledgement. So it will start a timer and it will wait for acknowledgement. If it receives the acknowledgement before the timeout, then the frame transmission is successful. So otherwise it has to retransmit. So positive acknowledgement and timeout timer guarantees receiving of frame by the receiver. That is why these are the three strategies we have in CSMA CA, mainly which avoids the collision. So this is the flow diagram of CSMA CA. So whenever there is a frame from the station, initially it will initialize k value equal to 0. Then it will sense the medium continuously. If the medium finds idle, then it will wait for IFS time, and then it will choose a random number r between 0 to 2 to the power k minus 1, and it will wait for some period of time, that is contention window. After that, it will send the RTS. So now here, this uh, concept mainly used in the wireless communication. So where RTS and CTS, we call it as control information. So RTS will be sent by the sender and CTS will be sent from the receiver. So this is a frame, control frame, which is transmitted before we actually send the frame, data frame. So that is why after waiting for some contention window, it will send a RTS. So RTS stands for request to send. So RTS stands for request to send, and it will start a timer. So before this timer expires, if the sender receives the CTS from this receiver, that is clear to send. So clear to send is shortly we call it as CTS. So this will be sent by the receiver to the sender. So if the sender receives this CTS before this timer, then again it will wait for IFS time. After that, it will send the frame. So here, one thing is, before sending the actual data frame, a control information will be shared between sender and receiver, that is RTS and CTS. So after sending the frame, it will start the timer. So if at all acknowledgement is received by the sender before this timer expires, then it is successful transmission. Otherwise, if the timer expires, it has to retransmit. So retransmission is same. So it will increment the value of k plus 1, k by k plus 1, and it will check for limit. If at all this limit is not reached, then it has to wait for TB and it has to retransmit. So this is what flow diagram for CSMA CA. So that's it. So in this video, so we have discussed CSMA protocol, what is the main idea behind CSMA protocol, and after that we have discussed about two variants of CSMA protocol, that is CSMA CD, which is designed for wired LAN, and after that we have discussed CSMA CA, which is designed for wireless LAN. So the next video we'll discuss about controlled access. So thank you. We'll meet in the next video.